Okay, sorry the other one was kind of sideways, so hopefully you can watch that on your phone and tilt the screen. Okay, for number 2, so we have a graph of f, and it says that g is the antiderivative of f. So let's go ahead and translate that from this sentence into math. So g is the antiderivative of f, which means that g prime, the derivative of g, will just be f, and g double prime, take derivative, will be f prime. So we've got this relationship right here, and then we also know that g of 1 is 4. So part A is asking for points of inflections on the graph of g. So let's think about point of inflection. You could say that g prime changes crescents, or you could say g double prime changes signs. Both of these are valid, but let's think about what we have. We have a graph of f, and we know that f is just equal to g prime. So I'm going to ignore g double prime, because f, which is g prime, is going to change, I'll say, from increasing to decreasing, or also decreasing to increasing, and then we'll just say the x values where that happens. So where f, or g prime, changes from increasing to decreasing is at x equals 1, and then decreasing to increasing at 0 and at 3. 1, 2, 3. So 0 and 3. Okay, and that's your full answer. B is asking for the minimum value of g on an interval. So I know for minimum value on an interval, I need to find the values at the endpoints and also at critical numbers. To find critical numbers, you take derivatives set equal to 0. We already know that g prime is f, so where f is equal to 0. This is a graph of f, so it's 0 right here, and right here. Negative 4 is already on our endpoint, so not worried about that. So at 1 and at 1, 2, 3, 4, 5. Now, I don't actually need to plug in both of these because I'm looking for a minimum value, so I only need to check the relative minimum. 1 isn't a minimum or a maximum, it's neither, right? It's not changing from signs, so I'm only really checking the critical number 5. It's not wrong if you check it 1, but you are wasting time that you don't need to. Okay, now I have to find all of these values. So remember, we have a graph of f, and I'm going to make a note that this is also g prime. I want to find g, and I know that g of 1 is 4. So if I can do the antiderivative of g prime, that will give me g of minus g of, like this. So if I know 1, I know g of 1, and I want negative 4, so let's do negative 4 to 1. And then the antiderivative from negative 4 to 1 would just be this area, which is 5 times negative 2, 5, negative 2 over 2. So this is negative 10 equals g of 1, it was given, is 4, minus g of negative 4. Subtract the 4 over, that's negative 14. Divide by negative, you get positive 14. This one is 14. Now I'm going to do the same things, but to find g of 5 and g of 7. So still no g of 1, looking for 5, so let's do 1 to 5. Area from 1 to 5 is this negative half circle with a radius of 2, so that's pi 2 squared over 2, which is 4 pi over 2, which is 2 pi, so this is just minus 2 pi, because it's on the bottom of the graph. G of 5, what I'm looking for, minus g of 1 is 4, so just add the 4 over, you get 4 minus 2 pi. And last thing, I want to go to 7, so I'll just do 1 to 7 of g prime. Looking for g of 7, g of 1 is 4, and then the area from 1 to 7 is this negative 2 pi plus 2 times 2 over 2, which is area of 2. Add the 4 over, this becomes 6 minus 2 pi. Okay, and then now I need to actually answer the question, which is the minimum value. This is like 4 minus 6 or 6 minus 6. So this right here is the minimum value of g. And that is your question. or your answer. Part C, it is giving me this h function, and I want to find h prime of negative 1, h double prime. So first, let's just find h prime of x. Derivative of 3x is 3 minus, for this, we're taking derivative of an antiderivative, so I'm definitely going to be left with f of something. Here, I have to plug in my new, like, I don't know, thing that I'm plugging in. It won't be of t anymore, it will be of 2x, and I need to multiply by the derivative of what I plugged in. I plugged in 2x, derivative of that is times 2. So this is my h prime of x. Now my h double prime of x, you'll just take the derivative of this. Derivative of 3 is 0. Derivative of this is just minus 2. I brought it out the front. Derivative times 2. So I'm going to rewrite this. This is 3 minus 2 f of 2x. To find h prime of negative 1, 3 minus 2 f of negative 2, f of negative 2, 1, 2. So we're right here, and I'm going to be at negative 1 right there? Yeah. So then 3 minus 2 times negative 1, and you can even just leave it like that. Of course, that becomes 3 plus 2, which is 5. Oh no. I have 6 as my answer. Did I do that wrong? Yeah, I think I did that wrong. I think it should be this. Okay, and now we plug in a negative 1 to h double prime. So this is, I'm just going to call it negative 4 f prime of negative 2. To get f prime from a graph of f, you just take the derivative. So I want the slope right here. Looks like you're going down to and over 4. So slope down to over 4, which is negative 1/2. And then plug in. You can just leave it like that. Obviously, that becomes positive 2. And I'm checking for continuity at x equals 0 for k in part D. So let's find the limit as x approaches 0 from the left of k of x. That would just be f of 3 minus 0 minus 0. F of 3, go to your graph, 1, 2, 3 is negative 2. So negative 2. Now I need to check the limit as x approaches 0 from the right of k of x. And that's going to be f of 0. F of 0 is also negative 2. These check out. So yes, k is continuous at x equals 0 because the limit as x approaches 0 from the right of k of x equals the limit as x approaches 0 from, oh, I said right, left, right, it doesn't matter the order actually, and that also equals k of 0, and I know it equals k or 0 because there was a or equal to sign, so you don't need to plug in a third time, right? You already kind of found that. So yes. And last one, E, it says, let's say that f is actually the velocity. I want to know the acceleration at t equals 1/2, and is the speed increasing or decreasing? So let's find a of 1/2. So a is just the derivative of the velocity, which will be the slope of the velocity. So go to 1/2. The slope right here looks like you're going up 2 and over 1, so that's a slope of 2. So you need that because it specifically asked to find the velocity at 1/2, or sorry, acceleration. And then the velocity at 1/2 is just the point because it said, what if this is your graph of v? So then you'll notice that this is a negative velocity because the point is negative. So this is negative. Now if you have a negative velocity and you have a positive acceleration, that means your speed is decreasing at t equals 1/2. Because a of 1/2 and v of 1/2 are opposite sides. Sorry, I ran out of room here. But that is a classic justification, is on your mega packet. That is, if you're asked about speeding up or slowing down or speed increasing or decreasing, you want to talk about the sign of a and v at that particular time. All right?